What does it mean to know where you are? For most of human history, this question was not a matter of glancing at a screen, but of staring at the stars, studying the shape of coastlines, and drawing lines on parchment that might mean life or death for the sailors who followed them. Maps are not just tools for navigation. They are portraits of how humanity imagined the world, full of guesses, dreams, and blank spaces marked with warnings of monsters. Tonight, we explore the art and science of cartography, the slow, patient work of turning an unknowable planet into lines on paper. From cave paintings that may be the oldest maps ever made, to the satellites that now measure every inch of the Earth, this is the story of how we learned to see the world from above. Welcome to Drowsy Discovery. Over the next 2 hours, over 100 gentle facts will unfold like an ancient map being carefully unrolled. There is nothing to memorize, nothing to remember. Just listen and let your mind wander across continents both real and imagined. Have you ever wondered how early explorers knew which way to sail, or why old maps placed Jerusalem at the center of the world? You are not alone. If these journeys across ink and parchment help you find rest, consider subscribing and becoming part of our community of curious sleepers. Now let your breathing slow like a ship finding calm waters. Feel the weight of your body settling as if you were lying on a shore watching the tide go out. The unknown territories of the night await you. Let us begin. The word cartography comes from the Greek words for map and writing. The name itself tells a story of how ancient peoples understood the making of maps, not merely as drawing, but as a form of writing, a way of inscribing the world onto a surface so that others might read the land as they would read a scroll. The Greek word charts referred to papyrus or parchment, while graphene meant to write or draw, and together they form a name that suggests maps were always meant to be documents of meaning, not just images of place. In the ancient world, the ability to record coastlines and mountains was considered a rare and precious skill, passed from scholar to scholar with great care, for a map could determine the fate of traders and the survival of sailors crossing unknown waters. Even today, the word cartography carries within it that ancient connection between writing and the world. To make a map is to compose a sentence about the Earth. The oldest known maps may be cave paintings over 20,000 years old. Deep inside caves in France and Spain, on walls that have not seen daylight for millennia, ancient humans painted images that some researchers believe are the earliest attempts at mapping the world. These markings show clusters of dots and shapes that seem to correspond to the landscape outside, perhaps representing hills, rivers, or hunting grounds that the artists knew from a lifetime of wandering. One painting in Lascaux appears to show the position of stars, suggesting that even 20,000 years ago, people were looking up at the night sky and trying to fix its patterns onto stone. The idea that our distant ancestors, sitting by firelight, felt the same urge we feel today to understand where they were is deeply moving, for it suggests that the desire to map our surroundings is woven into human nature. Every map begins with someone looking at the world and wanting to remember it. Ancient Babylonians created clay tablet maps over 4,000 years ago. In the fertile lands between the Tigris and Euphrates rivers, the Babylonians pressed wedge-shaped marks into soft clay to create some of the earliest surviving maps in human history, tablets that have endured for more than 4,000 years. These maps were practical documents showing property boundaries and the layout of cities, but one extraordinary tablet, known as the Babylonian Map of the World, went further, attempting to show the entire known universe as a disk surrounded by a bitter salt sea, with mysterious regions beyond where mythical creatures dwelt. The mapmaker who created this tablet was trying to answer a question that still haunts us today, the question of what lies beyond the horizon, in territories that no traveler has yet returned from to describe. Holding such a tablet, you can almost feel the weight of those ancient questions. Clay crumbles, yet the questions remain. Maps were once considered sacred objects, holding the secrets of the world. For much of human history, maps were not public documents, but closely guarded treasures kept in the vaults of kings and the secret chambers of trading companies, for the knowledge they contained could mean the difference between wealth and ruin. A map showing a safe route to distant spice islands was worth more than gold, because it represented years of dangerous voyages, the lives of sailors lost to storms, and the accumulated wisdom of navigators who had learned which currents to follow and which coasts to avoid. Emperors commissioned maps to understand the extent of their dominions, generals used them to plan conquests, and merchants kept them locked away to maintain their advantage over rivals. Even the act of making a map was sometimes seen as a sacred duty, a way of bringing order to the chaos of uncharted wilderness. Knowledge has always been power. The earliest maps showed only local territories, the lands a person could walk in a lifetime. Before the age of explorers and ocean voyages, the world of most people was measured in footsteps. In the distance, a person could walk from their village to the nearest river, from their fields to the forest edge. The maps they made reflected this intimate knowledge, showing paths through familiar woods, the location of springs, and the boundaries of neighboring territories, all drawn with the precision that comes from having walked these routes 1,000 times. There was a time when the entire known world might fit on a single piece of bark, because the world itself was small, bounded by mountains no one had crossed, by rivers no one had followed to their source. These local maps were personal documents, filled with meaning that only the people who made them could fully understand, like a private language spoken between mapmaker and land. Home was the center of everything. To make a map is to make a choice about what matters and what can be left out. No map can show everything, for the world contains more detail than any surface could hold, more roads and rivers and buildings than any eye could see at once, and so every cartographer must decide what to include and what to ignore, what to emphasize and what to leave blank. A map made for sailors will show the depth of harbors and the position of reefs, but may leave inland territories empty, while a map made for pilgrims will mark every shrine and sacred site, but care nothing for trade. This act of selection means that every map is a kind of argument, a statement about what matters in the world, and to look at a map is to see the priorities and the preoccupations of the culture that made it. A road map tells you how to drive, a political map tells you who claims which land, but none tells you everything. Every map is a story with details left out. And from the origins of mapmaking, we now turn to how the ancient Greeks imagined the shape of the earth. The ancient Greeks knew the earth was round over 2,000 years ago. Long before any ship had sailed around the world, long before photographs from space showed our planet as a blue marble, Greek philosophers looked at the evidence around them and concluded that the earth must be a sphere, not a flat disk as many believed. They watched ships disappear over the horizon hull first, with the mast remaining visible longest, and they noticed that the shadow cast by the Earth on the Moon during an eclipse was always curved, a shape that only a sphere could produce. Aristotle wrote about these observations, and his arguments were so convincing that educated people throughout the Mediterranean accepted the spherical Earth as fact. The idea that people once believed the Earth was flat is largely a modern myth, for ancient scholars spent centuries trying to work out just how large this sphere might be. Wisdom sometimes precedes proof. Eratosthenes calculated the circumference of the Earth with remarkable accuracy using shadows. In the 3rd century before our era, a Greek scholar named Eratosthenes stood in Alexandria and made one of the most brilliant measurements in science. using nothing more than a stick, the sun, and careful reasoning. He knew that on the summer solstice in Scene to the south, the sun shone directly into a deep well casting no shadow, while in Alexandria, a vertical stick cast a distinct shadow. By measuring the angle of that shadow and knowing the distance between the two cities, he calculated the circumference of the entire Earth to within a few percent of its true value. This achievement, accomplished with the simplest of tools, reminds us that the greatest discoveries often require not expensive equipment but clear thinking. Eratosthenes could not walk the circumference of the Earth, yet he understood its size with astonishing precision. A shadow and a question were enough. Ptolemy's geography became the standard reference for mapmakers for over 1,000 years. In the 2nd century of our era, a scholar named Claudius Ptolemy worked in the Great Library of Alexandria, gathering the geographical knowledge of the ancient world into a single monumental work that would influence mapmakers for more than a millennium. His geography was not itself a collection of maps, but a manual for making them, listing coordinates of thousands of places from Britain to China and explaining how to project the curved surface of the Earth onto a flat page. Even though some of Ptolemy's information was wrong, including an underestimate of the Earth's size that would later contribute to Columbus believing he could reach Asia by sailing west, his systematic approach became the foundation of all subsequent cartography. When Renaissance scholars rediscovered his work, they used it as the starting point for the great age of exploration. Old books can change the world. Ptolemy invented the system of latitude and longitude that we still use today. The grid of invisible lines that covers every globe and map, allowing us to specify any location with just 2 numbers, was first developed by Ptolemy nearly 2,000 years ago. And though the technology to determine these coordinates has changed, the basic concept remains exactly as he described it. Latitude measures how far north or south you are from the equator, longitude measures how far east or west from a reference line, and together these measurements can pinpoint any spot on Earth. This system transformed navigation from an art based on intuition into a science based on precise measurement, making it possible to create maps that could be combined and to build a shared picture of the world. The lines are imaginary, drawn not on the Earth itself, but only on our representations of it, yet they have guided countless ships safely home. Some inventions outlive their creators by millennia. The Greeks imagined lands beyond their maps, populated by strange creatures and distant peoples. At the edges of Greek maps, where reliable knowledge faded into rumor, the imagination filled the blank spaces with wonders that no traveler had truly seen. There were tales of the cynocephali, dog-headed men who barked instead of speaking, the blemmies, headless creatures with faces in their chests, and the cyapodes, beings with a single foot they used as a parasol against the sun. These creatures were not simply fantasies, for they reflected a deeper truth about how people understood the world, a belief that the further you traveled from the familiar, the stranger things became, until at the very edge of the known you might find anything at all. Such images persisted on maps for centuries, blending geography with mythology in ways that seem strange to modern eyes, but made perfect sense in a world where the unknown was truly unknown. The map's edge is where wonder begins. Many Greek maps showed the world as a disk surrounded by a great ocean. The ancient Greeks pictured the known world as a circular landmass with Greece at or near the center, surrounded by the great river Oceanus that flowed eternally around the rim of everything. This model made sense to people who understood that the Mediterranean connected the lands they knew, and who had heard sailors speak of reaching the edge of the world, where the sun dipped into waters so distant that no ship had returned from them. The disc-shaped world appeared in the poetry of Homer and the philosophy of the earliest Greek thinkers, and though later scholars would recognize the Earth as a sphere, the image of a flat disk remained powerful in the imagination. a picture of a world that was finite, knowable, and centered on the places its makers called home. Every civilization places itself at the center of its maps, and the Greeks were no different. We all draw the world from where we stand. And from the classical world, we now journey to the map-makers of the Islamic Golden Age. Islamic scholars preserved and expanded upon Greek cartographic knowledge during the medieval period. While much of Europe lost access to ancient learning during the centuries after Rome fell, scholars in the Islamic world carefully preserved, translated, and improved upon the geographic knowledge accumulated by Greek and Roman thinkers. In libraries from Cordoba to Baghdad, manuscripts containing Ptolemy's geography were copied, studied, and corrected where new information proved older accounts to be wrong, creating an unbroken chain of knowledge that would one day return to Europe and spark the age of exploration. These scholars did not merely preserve what others had written, but added their own observations gathered from merchants, sailors, and travelers who crossed deserts and oceans to reach the furthest corners of the known world. Without their dedication, centuries of accumulated wisdom might have been lost forever. Libraries can save civilizations. Al-Idrisi created one of the most accurate world maps of the medieval era in the 12th century. In the court of King Roger II of Sicily, a Muslim scholar named Al-Idrisi spent 15 years gathering information from travelers and sailors, merchants and pilgrims, combining their accounts with knowledge from ancient texts to create a map of the world more accurate than anything that had been made before. His great work, known as the Tabula Rogeriana, showed not only the Mediterranean world, but stretched to include the coasts of Africa, the interior of Asia, and lands far beyond what European mapmakers of the time could imagine. The map was accompanied by a book describing the peoples, cities, climates, and wonders of each region, a complete geography of the known world assembled with painstaking care at a time when such comprehensive knowledge was exceedingly rare. Al-Idrisi's work would influence mapmakers for centuries to come. Knowledge flows where minds are open. The House of Wisdom in Baghdad became a center for translating and improving ancient maps. In the 8th and 9th centuries, the Abbasid caliphs of Baghdad established a great institution known as the House of Wisdom, where scholars gathered to translate the scientific and philosophical works of ancient Greece, Persia, and India into Arabic, preserving knowledge that might otherwise have vanished. Among the texts that passed through this remarkable library were the geographical works of Ptolemy and other ancient mapmakers, works that were not simply copied, but actively improved as Arab geographers added new information gleaned from the vast trading networks that stretched across the Islamic world. The House of Wisdom became the intellectual center of the medieval world, a place where scholars of many faiths and backgrounds worked side by side to understand the earth and everything upon it. Great ideas need a place to gather. And as you rest with these ancient geographies, let them settle gently in your thoughts like ink spreading across parchment. There is no need to trace every line. Let your breath slow, your muscles soften, and allow the stillness to wrap around you. Islamic cartographers pioneered the use of color to distinguish different features on maps. While earlier maps often relied on simple outlines and text to convey information, Islamic cartographers developed sophisticated systems of color coding that could show at a glance the difference between mountains and plains, rivers and deserts, and the territories of different peoples. Blue marked bodies of water, green indicated fertile lands, yellow or brown showed deserts, and red often highlighted roads and important cities, creating maps that were not only more informative but more beautiful, works of art as well as practical tools. This use of color required expensive pigments and considerable skill, making the finest maps costly treasures commissioned by kings and wealthy merchants. But the techniques that Islamic mapmakers developed would eventually spread throughout the world and become standard practice. Color transforms information into understanding. Arab traders needed accurate maps to navigate trade routes stretching from Spain to China. The great trading networks of the medieval Islamic world stretched from the Atlantic coast of Morocco to the distant shores of China, passing through deserts, mountains, and perilous seas that required careful navigation to cross safely. Merchants who carried precious silk, fragrant spices, gold, and ivory across these enormous distances needed reliable information about the routes they would follow, the watering holes where they could rest their camels, the ports where ships could shelter from storms, and the cities where goods could be bought and sold. This practical demand for accurate geographic knowledge drove advances in map-making that might never have occurred if maps had remained purely scholarly objects, forcing cartographers to correct errors that traders discovered in the field. Commerce and curiosity walked the same roads. The astrolabe, perfected by Islamic scholars, allowed navigators to determine their position from the stars. The astrolabe was a remarkable instrument that allowed its user to measure the angle of the sun or stars above the horizon and calculate their position on Earth with considerable accuracy. Though the basic concept originated with ancient Greek thinkers, Islamic astronomers refined and perfected the device over several centuries, creating instruments of extraordinary precision and beauty, often engraved with intricate decorations and inscribed with the names of stars in flowing Arabic script. With an astrolabe in hand, a navigator crossing the featureless desert or the open ocean could look up at the night sky and know approximately where they were, an achievement in an age before clocks or compasses were widely available. The astrolabe made the stars into a map that could be read. Heaven became a guide for Earth. And from the Islamic world, we now cross into medieval Europe, where maps became tools of faith. Medieval European maps often placed Jerusalem at the center of the world. For the mapmakers of medieval Europe, the purpose of a map was not primarily to help travelers find their way from one place to another, but to illustrate the spiritual geography of God's creation. And so Jerusalem, the city where Christ had lived and died, was placed at the very center of the world, the point from which all else radiated outward. These maps showed the east at the top, where paradise was believed to lie, and the three known continents arranged around Jerusalem like petals around the heart of a flower, with Asia above and Europe and Africa below. Such maps were not meant to be geographically accurate, for accuracy was less important than meaning, and the message they conveyed was that the world had been created with a sacred center, a holy city toward which all believers should direct their hearts. Maps can show belief as clearly as terrain. Mappa Mundi was symbolic rather than practical, showing spiritual truths rather than accurate geography. The great medieval world maps known as Mappi Mundi were never intended to guide travelers or help sailors find their way across the seas, for they served a different and altogether higher purpose, offering a vision of the world as it was understood in the light of scripture and theology. On these maps you might find the Tower of Babel, the lands where the tribes of Gog and Magog awaited the end of days, the rivers flowing out from the Garden of Eden, and dozens of strange peoples and monstrous creatures described in ancient texts, all arranged not according to measurable distances, but according to their place in the divine order of creation. To modern eyes, these maps seem wildly inaccurate, but to medieval viewers they showed a deeper truth, the truth of a world created and governed by God. geography was theology. The Hereford Mappa Mundi is the largest surviving medieval map, over 1.5 meters across. In Hereford Cathedral in England, a great map drawn on a single calfskin still hangs where visitors can see a medieval vision of the world preserved across 800 years. This remarkable document shows Jerusalem at its center, with the Garden of Eden at the top in the east, and fills its surface with hundreds of drawings depicting cities, rivers, peoples, and creatures, both real and imagined. Looking at this map is like stepping into the mind of someone from another age, seeing the world not as satellite photographs would reveal it, but as faith and legend and travelers' tales had shaped it in the medieval imagination. The map contains over 1,500 inscriptions and images, from the British Isles drawn with recognizable detail to mythical races and beasts dwelling at the world's edge. Some truths are preserved in ink. Medieval maps often showed the Garden of Eden as a real place at the edge of the known world. For medieval Christians, the Garden of Eden was not simply a myth, but a physical location that existed somewhere beyond the known lands, usually placed at the easternmost edge of maps, where the sun rose over territories too distant for any traveler to have reached and returned to tell the tale. These maps showed paradise as a walled garden or island, often with 4 rivers flowing from it to water the lands of the world below, just as Scripture described, and mapmakers saw no contradiction between drawing this sacred place alongside the ports, roads, and trading cities that merchants actually used. The belief that one could theoretically walk to paradise, if only the journey were not so impossibly long and fraught with danger, gave the world a sense of enchantment that modern geography has perhaps lost. The edge of the map was where the sacred met the ordinary. Sea monsters and mythical creatures filled the blank spaces on medieval maps. In the empty oceans of medieval maps, where cartographers had no reliable information about what lay beyond the known shipping routes, artists filled the waters with serpents, whales, and fantastical beasts, some drawn from sailors' exaggerated tales and others from imagination running wild. These creatures served both decorative and practical purposes, warning travelers that they were entering dangerous and uncharted waters, while also admitting that the mapmaker did not know with certainty what actually lived in those distant seas. Some of the monsters were loosely based on real animals, with whales, walruses, and giant squid transformed into terrifying leviathans by imagination and fear. The sea was truly an unknown world, and the monsters that filled the empty waters expressed both the danger and the wonder of what might lie beyond the familiar horizons. Every blank space calls for a creature. The phrase "here be dragons" appeared on maps to mark unexplored territories. The famous warning "here be dragons" has become a symbol of all the mysterious and dangerous unknowns that mapmakers had to acknowledge when their knowledge ran out, though in truth, this exact phrase appeared on very few actual surviving historical maps. What it represents, however, was very real indeed: the practice of filling uncharted regions with warnings, monsters, and ominous labels that admitted the cartographer had no reliable idea what actually lay in those distant and unexplored lands. The Huntlenix globe, made around 1510, bears a Latin phrase describing dangerous or unknown regions in words that echo the dragon warning. Whether written in Latin or English, such warnings served as honest admissions of ignorance in a world where venturing beyond the known could mean sailing off into true danger. The unknown always deserved respect. And from the symbolic maps of medieval Europe, we now sail into the age of exploration. Portolan charts were the first maps accurate enough for practical navigation at sea. Beginning in the 13th century, a new kind of map appeared in the trading ports of the Mediterranean that would transform sea travel forever. Charts so accurate that sailors could actually use them to navigate from one harbor to another without relying purely on experience, memory, and the guidance of those who had sailed the route before them. These portolan charts showed coastlines with remarkable fidelity, marked with hundreds of place names and crisscrossed with lines radiating from compass roses that helped navigators plot their courses across open water. Unlike the symbolic Mappi Mundi that showed spiritual truths about creation, portolan charts were working documents drawn from practical observation and careful measurement. They were the tools of merchants and admirals who needed to know the real shape of shores. Accuracy became necessary for commerce and survival. Portolan maps were drawn on animal skins and showed coastlines with remarkable precision. The finest portolan charts were drawn on vellum, the carefully prepared skin of calves or sheep, a surface strong and supple enough to withstand the salt spray and rough handling of life at sea, while holding ink with remarkable clarity for decades or even centuries of continuous use. These charts were created by specialists who compiled information from countless voyages, checking sailors' reports against each other to build an increasingly accurate picture of how the coastlines actually ran and where the dangers lay waiting beneath the waves. The precision of the best portolan charts amazes modern historians, for they show harbors and headlands in shapes recognizably close to what satellite photography would reveal centuries later. Such accuracy required patience, collaboration, and careful observation over many generations. Every coastline was drawn in sailors' blood. The compass rose became a standard feature on navigational maps, pointing the way to far shores. Every portolan chart was marked with one or more compass roses, beautiful geometric designs from which lines radiated in all directions across the parchment, allowing navigators to set their courses across the trackless sea by laying a straight edge from their position to their intended destination on the far shore. These roses were often elaborately decorated, with the cardinal directions marked by distinctive designs and the intermediate points shown in careful gradations, and they became one of the most recognizable and enduring features of nautical cartography throughout the world. The compass rose transformed a simple piece of vellum into a powerful tool that could guide a ship hundreds of miles from home to a precise destination across dangerous waters. Without this elegant device, the age of exploration might never have unfolded as it did. A simple diagram changed history. Prince Henry, the navigator, established a school for cartography and navigation in Portugal. In the 15th century, a Portuguese prince who never personally sailed on any of the voyages he sponsored became one of the most important figures in the history of exploration, gathering mapmakers, skilled navigators, and experienced shipbuilders at a center in Sagres where they could share knowledge and improve their craft together. Prince Henry sent expedition after expedition down the coast of Africa, pushing Portuguese ships further into unknown waters each time, and carefully collected the information they brought back to create ever more accurate charts of waters that no European had sailed before. His investments in cartographic knowledge laid the foundation for the great voyages that would eventually round the Cape of Good Hope and reach India by sea. The prince understood that exploration required preparation. Every voyage began in the mapmaker's studio. Columbus carried maps that dramatically underestimated the size of the Earth. When Christopher Columbus sailed west from Spain in 1492, he carried maps based on calculations that made the Earth much smaller than it actually is, placing Asia so close across the Atlantic that a voyage of just a few weeks would reach the Spice Islands and the wealthy courts of the East. These errors came partly from mistakes in Ptolemy's ancient calculations, partly from optimistic estimates of how far East Asia extended beyond what any European had visited, and partly from Columbus's own wishful thinking, for he needed to convince his patrons that the voyage was possible and would bring them riches. Had his maps been accurate, he would have known that a vast, unknown continent blocked his westward path, and that Asia lay thousands of miles further than he believed possible to sail. Sometimes, the wrong map leads to the right discovery. The discovery of the Americas forced cartographers to completely redraw their picture of the world. When news of Columbus's discoveries reached Europe, mapmakers suddenly faced and confronted a crisis unlike any they had encountered before. For the comfortable world they had mapped and studied for centuries had just expanded beyond all recognition into strange new territories. These vast new lands had no place in Ptolemy's ancient geography, no mention in the texts of classical scholars, no presence in the careful calculations of latitude and longitude that generations of learned men had refined over centuries. In just a few decades, the maps of the world were transformed, with strange new coastlines appearing where only empty ocean had been shown before, and blank spaces opening up that would take centuries to fill with accurate detail. The discovery of the Americas was a disruption to everything cartographers thought they knew about the world. New worlds demand new maps. And from the shock of new continents, we now turn to the mapmakers who shaped our modern view of the world. Gerardus Mercator created the map projection that still dominates classrooms and websites today. In 1569, a Flemish cartographer named Gerardus Mercator published a New World map designed to help sailors navigate across the open seas. And though he could not have imagined it at the time, his projection would become the most influential and most widely seen representation of the Earth for centuries to come. The Mercator projection made it possible to draw straight lines on a map that corresponded to constant compass bearings, which was invaluable for ocean navigation when ships relied on compasses to chart their courses across featureless expanses of water. Today, despite the availability of more accurate projections for different purposes, the Mercator map still dominates our visual understanding of the world, appearing in classrooms, textbooks, websites, and online mapping applications used by billions. One cartographer shaped how the world sees itself. The Mercator projection distorts the size of landmasses near the poles, making Greenland appear larger than Africa. While the Mercator projection succeeded brilliantly at its original purpose of aiding navigation, it came with a significant visual cost that has shaped the way generations have perceived the relative sizes of continents and countries. Near the equator, the projection represents sizes reasonably well, but as you move toward the poles, the distortion increases dramatically, stretching landmasses until they appear far larger than they actually are. Greenland, for example, appears roughly the same size as Africa on a Mercator map, when in reality Africa is about 14 times larger. This distortion has had real effects on how people understand geography, with northern countries appearing more prominent and southern continents seeming smaller than they truly are. Our mental maps are shaped by the maps we see. Mercator's projection was designed for sailors, allowing straight lines to represent constant compass bearings. The genius of Mercator's projection lay not in showing the world accurately, but in solving a specific navigational problem that had troubled sailors and ship captains for generations before him. On a Mercator map, if you draw a straight line between 2 points, that line represents a path of constant compass bearing, known as a rhumb line, which meant a navigator could simply draw a line on the chart and sail that heading without constant recalculation of angles and positions. This was revolutionary for ocean voyages, allowing ships to cross vast stretches of open water with greater confidence that they would reach their intended destinations safely and efficiently. While mathematically not the shortest path, the rum line was far easier to follow with the navigational tools available to sailors of the age. Sometimes, the useful answer matters more than the perfect one. Abraham Ortelius published the first modern atlas in 1570. In 1570, the Flemish cartographer Abraham Ortelius gathered together the best available maps from various sources, standardized their formats, and bound them into a single comprehensive volume called the Theatrum Orbis Terrarum, which translates as Theater of the World, creating what historians consider the very first true modern atlas. Before this revolutionary publication, anyone wanting a complete picture of the known world would have had to collect individual maps from different makers, often at different scales and in varying styles. Ortelius changed everything by presenting a unified view of the world in one carefully organized book, complete with citations crediting the original mapmakers whose work he had compiled and standardized. His atlas went through dozens of editions and translations, becoming the essential geographical reference for educated Europeans. One book unified our view of Earth. The word atlas comes from the Greek titan, condemned to hold up the sky. The word atlas, which we now use for any bound collection of maps, comes from the mighty Greek titan who was condemned by Zeus to hold up the celestial sphere for all eternity as punishment for siding with the Titans in their ancient war against the Olympian gods long ago. Mercator himself chose to use an image of Atlas bearing the weight of the heavens on the cover of his collection of maps, and the name gradually became synonymous with any similar bound collection of geographical representations of the world and its many lands. It is a fitting metaphor, for an atlas truly does contain the entire world within its pages, holding up a representation of the earth, just as the mythological Titan held up the heavens above. Every time we open an atlas, we are symbolically taking the weight of the world into our hands. Ancient myths live on in modern words. Map-making became a competitive industry in the Netherlands during the 17th century. During the 17th century, the Netherlands emerged as the undisputed center of European map-making, with Amsterdam becoming a hub where the finest cartographers competed to produce the most accurate, most beautiful, and most commercially successful maps and atlases. The Dutch dominance in map-making was closely tied to their maritime empire and trading networks, which provided both the demand for accurate charts and the wealth to patronize skilled cartographers and engravers. Great publishing houses like those founded by Willem Bleeu and his son Joan produced atlases of extraordinary beauty, with detailed engravings, hand-colored illustrations, and the finest paper available, turning maps into works of art as well as practical tools. Dutch maps were exported throughout Europe and beyond, shaping how the entire world visualized geography. Commerce and artistry flourished together. And from the golden age of Dutch cartography, we now explore the technical challenges of mapping the Earth. It is impossible to perfectly flatten a sphere onto a flat surface without distortion. There is a fundamental mathematical truth that every cartographer must accept, a truth that makes perfect flat maps of the Earth forever impossible, and that is the simple fact that you cannot unwrap a sphere onto a flat surface without stretching, tearing, or compressing it somewhere. Try peeling an orange and flattening the skin completely, and you will see the problem that has challenged mapmakers for centuries. The Earth is a three-dimensional globe, and any two-dimensional representation must make compromises, choosing which properties to preserve and which to sacrifice for the sake of flatness. This is known as the distortion problem, and it affects every flat map ever made or ever to be made, no matter how sophisticated the mathematics behind it. Every flat map tells a partial truth and a partial lie. This is not a failure of cartography, but an acknowledgement of geometric reality. There are hundreds of different map projections, each making different compromises. Because no single flat map can accurately represent all the properties of a spherical Earth at the same time, mathematicians and cartographers have developed hundreds of different projections over the centuries, each designed to preserve certain properties while sacrificing others in ways that suit different purposes and needs. Some projections preserve area, ensuring that the relative sizes of landmasses are shown correctly even if their shapes are distorted. Others preserve shape locally, making coastlines and borders look accurate even if sizes become misleading. Still others preserve distance or direction from a single central point, which can be useful for specialized navigation and planning purposes. The choice of projection depends entirely on what the map is meant to show and what distortions are most acceptable for that particular use. Every projection is a choice about what matters most. The Peters projection shows all countries in their true relative sizes, but distorts their shapes. In 1973, the German historian Arno Peters promoted a world map projection that he argued was fairer and more accurate than the Mercator, because it showed all countries in their correct relative sizes, giving Africa, South America, and other equatorial regions their proper visual prominence, rather than shrinking them next to stretched northern landmasses. The Peters projection, technically a variant of earlier equalaria projections, sparked controversy and debate among cartographers, some of whom pointed out that while it corrected size distortions, it introduced significant shape distortions, making continents appear stretched and unfamiliar. The debate highlighted how maps are never neutral representations, but always involve choices that reflect priorities and values. Peters sparked a conversation about fairness in maps. Every flat map of the Earth is a beautiful lie, a necessary distortion of reality. When we understand that every flat map is fundamentally a compromise, a necessary distortion of reality rather than a perfect copy of it, we can begin to appreciate both the art and the science of cartography in a deeper and more meaningful way than before. The mapmaker must choose what to preserve and what to sacrifice, what to emphasize and what to diminish, and these choices shape how we understand the world around us in ways both subtle and profound. There is something beautiful in this fundamental impossibility, in the knowledge that we can never capture our spherical planet perfectly on a flat page, and yet we keep trying, creating ever more ingenious projections and ever more stunning visualizations of our shared home. Every map is both a truth and a lie, both a representation and an interpretation. The lie is necessary and the beauty is real. Let these geometric truths settle gently over you like a map being folded and put away. There is no need to measure or calculate. Simply breathe and let your body sink deeper into stillness. The problem of longitude took centuries to solve and cost countless lives at sea. While sailors could easily determine their latitude by measuring the angle of the sun or the stars above the horizon, determining longitude, their position east or west, remained one of the most dangerous unsolved problems in maritime history for many long centuries. Ships that miscalculated their longitude would find themselves wrecked on unexpected shores, or would sail past their destinations entirely, running out of food and water as they searched for land that should have appeared days earlier. The problem was fundamentally one of time, since the Earth rotates 15 degrees of longitude every hour, and without a reliable clock that could keep accurate time during months at sea through storms and temperature changes, sailors had no way to know how far east or west they had traveled. Thousands perished because of this simple unknown. A clockmaker named John Harrison finally solved the longitude problem with an accurate marine chronometer. In the 18th century, after decades of working alone in his quiet workshop, an English clockmaker named John Harrison created a marine chronometer so accurate and so robust that it could keep precise time even during long ocean voyages through storms, temperature shifts, and the constant motion of the waves. With an accurate clock set to Greenwich time, a navigator could compare local noon, when the sun was at its highest, to the time shown on the chronometer and calculate exactly how many degrees of longitude they had traveled east or west from their starting point. Harrison's achievement saved countless lives by finally giving sailors a reliable way to know their position, transforming navigation from a dangerous guessing game into a precise science. One dedicated craftsman's tireless work changed the sea forever. The prime meridian at Greenwich was only internationally adopted in 1884. For most of history, different nations used their own capital cities or observatories as the 0 point for measuring longitude, which meant that maps from different countries were difficult or impossible to compare with one another with any degree of precision. In 1884, delegates from 25 nations gathered in Washington, D.C., and agreed to adopt the Greenwich Meridian in England as the international prime meridian, the line from which all longitude would be measured as either east or west. The choice of Greenwich reflected Britain's dominance in maritime navigation and the widespread use of charts already based on that line, though France abstained and continued using the Paris meridian for decades afterward. Today, the imaginary line through Greenwich divides the eastern and western hemispheres. One agreed line unified our measurement of Earth. And from the mathematics of location, we now turn to the great surveying expeditions that measured the Earth. Triangulation allowed surveyors to measure vast distances by calculating angles from known points. The technique of triangulation revolutionized the science of surveying by allowing mapmakers to measure enormous distances without ever having to physically traverse the difficult terrain between their observation points. By measuring the angles from two known points to a distant third point and knowing the exact distance between those two starting points, surveyors could calculate the position of the third point with remarkable accuracy, then use that new point to continue measuring even further into the landscape. This method allowed the mapping of entire continents with a precision that would have been impossible through direct measurement alone, building up vast networks of connected triangles that stretched across mountains, valleys, and plains. Geometry became the surveyor's most powerful tool for conquering distance. The Great Trigonometric Survey of India took over 70 years to complete. Beginning in 1802 and continuing for over 7 remarkably long decades, the Great Trigonometric Survey of India was one of the most ambitious mapping projects ever undertaken, an effort to measure the entire subcontinent with scientific precision using enormous triangulation networks that stretched from the southern tip to the Himalayan peaks far in the north. The survey employed thousands of workers, used massive theodolites that had to be carried through jungles and up mountains, and faced dangers ranging from tigers and snakes to malaria and extreme weather conditions. Along the way, the surveyors measured the heights of the world's tallest peaks, including what would eventually be named Mount Everest after a former surveyor general. The survey created the foundation for modern maps of India. Science and determination conquered an entire subcontinent. The height of Mount Everest was first calculated by surveyors working hundreds of kilometers away. In 1856, the Great Trigonometric Survey announced that Peak XV in the towering Himalayas, which would later be named Everest, was the highest point on Earth. A remarkable conclusion reached not by anyone climbing to the summit, but by surveyors taking careful measurements from observation stations on the plains of India hundreds of kilometers to the south. By measuring the angles to the distant peak from multiple known positions and applying rigorous trigonometric calculations, they determined its height with surprising accuracy, calculating it at 29,002 feet, remarkably close to modern measurements made with satellites and advanced instruments. The mountain was conquered by mathematics long before anyone stood upon its summit. Distant observations revealed the roof of the world. Many surveyors died from malaria and other diseases while mapping remote territories. The great surveying expeditions of the 18th and 19th centuries were not just scientific endeavors, but also frequently dangerous and deadly ones. With malaria, cholera, dysentery, and other tropical diseases claiming the lives of countless surveyors, their assistants, and the local workers who carried the heavy equipment through dense jungles, swamps, and treacherous mountain passes far from home. In India alone, entire survey teams were sometimes wiped out by fever, and many of the names recorded in survey records are followed by notes of death from disease contracted in the field. The maps we take for granted today were often drawn with the lives of those who ventured into remote territories where medicine could not follow and help was impossibly far away. Every line on old survey maps represents someone's courage and sacrifice. The Ordnance Survey began as a military project to map Britain in case of invasion. The Ordnance Survey, which today produces the detailed maps beloved by hikers, geographers, and planners throughout the United Kingdom, began not as a peaceful civilian project, but as a military necessity following the Jacobite risings of the 18th century, when the government realized that precise maps were essential for moving troops quickly and defending against any future invasions or rebellions. The Board of Ordnance, responsible for military engineering and artillery, commissioned the first systematic survey of the British Isles, using triangulation networks to create accurate large-scale maps that would serve strategic purposes. Over time, the military mission expanded into a comprehensive national mapping effort that now covers every corner of the country in extraordinary detail. War's demands gave birth to peaceful exploration. Early surveying expeditions carried their equipment on the backs of elephants and camels. The great theodolites and other precision instruments used in the major surveying expeditions of the 19th century were often enormous and incredibly heavy, requiring entire teams of porters or pack animals to transport them through difficult terrain where no roads existed and no wheels could possibly pass through. In India, elephants were used to carry the massive instruments through dense forests and across rivers, while in desert regions, camels bore the burden of scientific progress across shifting sands and rocky wastes. The logistics of moving these delicate and expensive precision instruments safely through jungles, mountains, and deserts, while keeping them protected from moisture, heat, and damage, was itself a quite remarkable feat of organization and planning. Giants of nature carried the tools of science into the unknown. And from the great surveys of empire, we now turn to the maps that shaped how people thought about their world. Maps have always been tools of power, used by empires to claim and control territory. Throughout history, maps have never been merely neutral representations of geography, but have always served as powerful instruments of power, used by rulers and empires to stake claims to territory, to plan conquests and colonizations, and to impose order and control over lands and peoples far from the centers of power. Drawing a border on a map was often the first step in making that border real, as colonial powers carved up continents according to lines drawn in distant capitals by people who had never set foot on the lands they were dividing. Maps showed who owned what, who had the right to be where, and whose names would be remembered while others were forgotten, making cartography one of the most political of all the sciences throughout human history. Maps both reflected and reinforced the power of those who made and owned them. Colonial mapmakers often ignored or erased the names and boundaries of indigenous peoples. When European cartographers drew their maps of colonized lands, they frequently disregarded or deliberately erased the names that local peoples had used for mountains, rivers, valleys, and settlements for countless generations, replacing them with European names that honored distant kings, queens, explorers, and officials who had never walked those lands. This cartographic erasure was not merely a matter of convenience or ignorance, but was often a deliberate act of cultural subjugation, denying the existence and sovereignty of the peoples who had lived on those lands long before the mapmakers arrived with their instruments. The places remained the same, but the names changed, and with them the stories and histories that those names had carried for thousands of years were pushed aside into silence. Maps can erase as easily as they can record. Straight-line borders drawn by distant cartographers have caused conflicts that persist to this day. Many of the borders that still exist around the world today, particularly in Africa and the Middle East, were drawn by European powers at conferences and negotiations far from the lands they were dividing, with rulers drawing straight lines across maps that ignored the ethnic, linguistic, religious, and tribal boundaries that had existed for centuries before colonization. These arbitrary borders, drawn for the convenience of distant empires rather than the welfare of local peoples, divided communities, separated families, and created nations that combined peoples with no shared history or culture, while splitting others who had always lived together as one. The consequences of these cartographic decisions, made with rulers and pens in distant capitals, continue to fuel conflicts, tensions, and suffering that persist to this day. Lines on maps became wounds on the land. Propaganda maps were used in wartime to shape public perception of the enemy. During times of war, maps became powerful weapons of propaganda, used by governments and military planners to shape public perception of enemies, to justify territorial claims and military actions, and to rally populations behind their nation's cause by presenting carefully distorted views of geography and threat. Maps could make enemy nations appear larger and more menacing and threatening, could exaggerate the extent of enemy-held territory, or could visualize invasion arrows and military movements in ways designed to inspire fear or patriotic fervor in viewers at home. The deliberate use of color, projection, emphasis, and carefully chosen symbols allowed propagandists to tell whatever story they needed, turning the supposedly objective science of cartography into a tool of psychological warfare. In war, even maps become weapons carefully aimed at hearts and minds. The color pink on British Empire maps came to represent a quarter of the world's land surface. At the height of the British Empire, the convention of coloring British territories in pink or red on world maps created a striking and unmistakable visual image that demonstrated the extent of imperial power spanning the globe, with pink stretches of land appearing on every inhabited continent, and the phrase "the sun never sets" on the British Empire becoming a statement of cartographic as well as political truth. The choice of pink was partly practical, as it showed up clearly against other colors and was easily reproduced by the printing technologies of the time, but it also became a powerful symbol of empire, burned into the minds of generations of schoolchildren who studied these maps in their classrooms. At its peak, that pink covered nearly a quarter of the world's land surface. Color became a statement of dominion. Countermapping movements today try to restore indigenous place names and perspectives to modern maps. In recent decades, indigenous communities and their allies around the world have begun the work of countermapping, creating new maps that restore traditional place names, acknowledge indigenous territories and sacred sites, and present geography from the perspectives of peoples whose voices were long silenced by colonial cartography. These countermaps challenge the assumption that European maps represent the only valid way of understanding and representing the land, offering alternative views that incorporate indigenous knowledge, oral histories, and relationships with the landscape. The work of reclaiming cartographic representation is part of broader movements for indigenous rights and recognition around the world, using the power of maps to tell stories that were nearly lost. Ancient names are finding their way back onto modern maps. And from the politics of mapping, we now explore the curious world of phantom islands and mapmaker errors. Phantom islands appeared on maps for centuries before being proven not to exist. Throughout the long history of mapmaking, islands that never existed have appeared and persisted on maps for centuries, sometimes based on misidentified sightings of clouds, fog banks, or optical illusions at sea, and other times copied from earlier maps without anyone ever verifying their existence through actual exploration or survey. These phantom islands took on a life of their own in cartographic tradition, passed from mapmaker to mapmaker as authoritative features of the ocean, complete with names, coordinates, and sometimes even detailed coastlines drawn by cartographers who had never seen them with their own eyes. Some phantoms survived on charts until modern times, when satellite imagery finally proved beyond doubt that they did not and never had existed anywhere except on paper. Imaginary lands haunted real maps for generations. The mountains of Kong blocked explorers across West Africa on maps, but were entirely imaginary. For nearly a century, European maps of Africa showed a massive east-west mountain range called the Mountains of Kong stretching across West Africa, blocking all travel to the interior and supposedly explaining why so little was known about the lands beyond. The mountains first appeared on an influential 1798 map based on vague reports and speculation, and once established in cartographic tradition, they were copied by mapmaker after mapmaker without question for many decades after. It was not until determined explorers actually traveled through the region in the mid-19th century that the mountains were finally proven to be entirely imaginary, a phantom range born from rumor and perpetuated by the trust cartographers placed in earlier maps. An entirely imaginary barrier blocked exploration on paper alone. California was shown as an island on many maps for over a century. One of the most famous and persistent errors in cartographic history was the depiction of California as an island, separated from the mainland by a mythical inland sea or strait, a mistake that appeared on maps from the early 17th century and persisted in various forms for over 150 years, despite occasional explorers reporting that no such sea existed. The error likely originated from garbled reports of early Spanish expeditions to the Gulf of California, combined with European hopes for a northwest passage, and once established on influential maps, it proved remarkably difficult to correct even when contradictory evidence emerged. It took a royal decree from the King of Spain in 1747, officially declaring California to be part of the mainland, to finally end the island myth on official Spanish charts. Geography itself required royal intervention. Mapmakers sometimes inserted fake towns called trap streets to catch plagiarists. Knowing that competitors and plagiarists might simply copy their painstakingly compiled work, Some cartographers developed the clever practice of inserting small deliberate errors into their maps, tiny fictional streets, non-existent towns, or subtle misspellings that would serve as fingerprints, proving theft if they appeared on a competitor's supposedly original map. These traps, sometimes called Easter eggs or copyright traps, could be remarkably subtle: a tiny cul-de-sac that did not exist, a building slightly out of place, or a fictional village nestled quietly among real ones nobody would think to verify. The practice continues to this day, with modern mapping companies reportedly inserting their own traps to catch digital plagiarists who copy their data without permission. Even maps contain hidden secrets waiting to catch unwary thieves. Sandy Island appeared on maps and even Google Earth despite not existing. As recently as 2012, an Australian research vessel sailed to the coordinates of Sandy Island, a small island that had appeared on maps and charts since the late 19th century and was clearly visible on Google Earth and other modern mapping services, only to find nothing but open ocean 2.5 kilometers deep where land should have been. The island, supposedly located between Australia and New Caledonia in the South Pacific, had been recorded by whalers in 1876 and had somehow survived on charts, in databases, and in official records for over a century without anyone checking whether it actually existed. Its removal from modern digital maps served as a humbling reminder that even in the age of satellites and global positioning systems, phantom geography can still persist quietly on our maps. Not all shores are real, even digital ones. Some errors on ancient maps were copied from mapmaker to mapmaker for generations. In the world of historical cartography, errors had a remarkable tendency to persist and spread, passed from one mapmaker to the next, as each new cartographer consulted and copied from the works of their predecessors, often without any attempt to verify the information through original observation or exploration. An error made by a respected authority could be repeated for centuries, appearing on map after map, gaining the weight of tradition and becoming almost impossible to question once it had been established as cartographic fact by generations of copying. This chain of repetition meant that mistakes could take on a life of their own, outliving the original mapmaker and becoming embedded in the cartographic tradition long after anyone remembered where the error first arose. Authority then flowed from repetition rather than verification. And from the mistakes of mapmakers, we now turn to the artistic beauty of historical maps. Decorative cartouches on old maps often depicted scenes of local life and exotic animals. The finest historical maps were not merely functional tools for navigation and planning, but were also genuine works of art, adorned with elaborate decorative elements called cartouches, which were ornate frames containing the map's title, scale, compass rose, and other information, often surrounded by illustrations depicting the flora, fauna, and peoples of the regions being mapped. These cartouches might show indigenous peoples in traditional dress, exotic animals that European audiences had never seen with their own eyes, or scenes of commerce, agriculture, and daily life that added both beauty and information to the cartographic representation. The best cartouche artists were skilled engravers whose meticulous work transformed printed maps into treasured objects worthy of display and collection. Maps became windows into distant worlds, decorated with wonder. Sea monsters on maps were often based on real sightings of whales, seals, or giant squid. While the sea monsters that populated the oceans of historical maps might seem purely fantastical to modern eyes, many of them were actually based on real animals that sailors had glimpsed from the decks of their ships, filtered through fear, imagination, and the distortions of memory and retelling over many long voyages at sea. Whales spouting in the distance, walruses hauling themselves onto ice, giant squid rising from the depths, and unfamiliar seals with strange faces all contributed to the rich bestiary of sea creatures that cartographers drew to fill the empty waters of their maps. These creatures served both decorative and informational purposes, warning sailors of the dangers and wonders that awaited in distant seas, while also filling blank spaces with artistic invention. Real animals inspired the imaginary monsters that swam on paper. The finest historical maps were hand-colored, with pigments made from minerals and plants. Before the development of color printing, the finest maps were printed in black ink from engraved copper plates, and then carefully hand-colored by specialized artists who applied delicate washes of natural pigment made from crushed minerals, dried plants, and other natural materials, each color requiring its own special preparation and care. Green might come from verdigris, blue from precious lapis lazuli or indigo, red from vermilion or madder root, and the most precious and expensive colors were reserved for the most important features or the wealthiest clients who could afford the extra expense of such luxuries. This meticulous work transformed printed maps into unique hand-finished objects, no two exactly alike, each bearing the subtle marks of the individual artist who colored it. Every colored map was painted by human hands. Some maps were illuminated with gold leaf, turning them into works of art as well as navigation tools. The most prestigious and expensive maps produced during the Renaissance and early modern period were illuminated with real gold leaf, thin sheets of hammered gold carefully applied by skilled craftsmen to highlight borders, titles, compass roses, and other decorative elements, transforming functional navigation tools into dazzling works of art fit for royal collections and noble libraries. These golden maps were never meant for use at sea, but were created as display pieces, diplomatic gifts, and symbols of wealth and knowledge, commissioned by kings, princes, and wealthy merchants who wanted to demonstrate their sophistication and worldly understanding. The gleaming gold caught the candlelight in private chambers, reminding viewers that knowledge of the world was itself a precious and valuable treasure. Geography itself became gilded. And as you rest with these beautiful images, let them drift through your mind like clouds passing over a painted landscape. There is no need to memorize any detail. Simply breathe and let the quiet settle around you. Antique maps are now collector's items, with the finest examples selling for millions of pounds. Today, the finest antique maps have become highly sought-after collector's items, with rare and beautiful examples by famous cartographers like Mercator, Ortelius, and Blieu selling at auction for hundreds of thousands or even millions of pounds, far more than anyone would have imagined when they were first printed centuries ago as working documents for navigators and scholars. Collectors prize these maps not only for their historical significance and artistic beauty, but also for their tangible connection to moments of discovery and exploration that shaped our modern world in lasting ways. The handmade quality of historical maps, with their hand-colored pigments and inevitable small variations, gives each example a unique character that mass-produced modern prints simply cannot match. Old maps have become treasures worth fortunes. And from the beauty of old maps, we now ascend into the sky with aerial photography and satellites. The first aerial photographs were taken from hot air balloons in the 19th century. The long dream of seeing the Earth from above, which had long been the exclusive perspective of birds and clouds alone, became reality in the 19th century when adventurous photographers began ascending in hot air balloons with their bulky cameras to capture the first true aerial images of cities, landscapes, rivers, and countryside below. These early aerial photographers faced enormous technical challenges, from keeping their heavy glass plate cameras stable in swaying baskets to timing exposures correctly with the primitive technologies available at the time. But their pioneering images revealed a completely new way of seeing the world that would eventually transform cartography forever. Looking down from the sky, features invisible from ground level became suddenly clear and legible. The bird's-eye view became reality at last. Military reconnaissance during World War I led to major advances in aerial mapping. The terrible trench warfare of the First World War created an urgent military need for accurate maps showing enemy positions, fortifications, and movements, driving rapid advances in the science of aerial photography and photogrammetry that would transform cartography for both military and civilian purposes in the decades that followed. Reconnaissance aircraft flew over the battlefields daily, capturing images that were quickly developed and analyzed by specialists who could read the landscape of war from above, identifying trenches, artillery positions, supply lines, and troop concentrations invisible to observers on the ground. The techniques developed under the pressure of wartime necessity were later applied to peaceful purposes, making possible the systematic aerial mapping of entire countries and continents. War accelerated the mapping of the world from above. Spy satellites during the Cold War produced maps more detailed than anything previously possible. During the Cold War, both superpowers launched spy satellites equipped with cameras of truly extraordinary resolution, capable of capturing details from hundreds of kilometers above the Earth that would have seemed utterly impossible to earlier generations of mapmakers and military planners alike. These orbital eyes circled the planet continuously, photographing military installations, cities, agricultural areas, and natural features with a level of detail that made previous aerial photography seem crude by comparison. While the images remained classified for decades, the technologies developed for espionage eventually filtered into civilian applications, making possible the detailed satellite imagery we now take for granted in everyday mapping applications. Secrets gathered from space reshaped how we could all see the world. Satellite imagery now allows us to watch ice sheets melt and forests shrink in real time. Modern Earth observation satellites continuously photograph and monitor the planet's surface day and night, allowing scientists and researchers to track environmental and ecological changes that would have been impossible to measure in earlier eras, from the shrinking of polar ice caps and glaciers to the expansion of deserts, the clearing of tropical rainforests, and the growth of cities sprawling across the landscape. This constant stream of imagery has transformed our understanding of how rapidly the Earth is changing under human influence, providing the evidence that informs debates and decisions about climate change, conservation, and sustainable development around the world. Maps are no longer static snapshots, but have become dynamic records of a planet in constant flux and transformation. The Earth's changes are now visible from space. The entire surface of the Earth has now been photographed from space in high resolution. Thanks to decades of satellite missions and the continuous expansion of orbital imaging capabilities, every square kilometer of the Earth's land surface has now been photographed from space in high resolution, creating a comprehensive visual record of our planet that would have seemed like pure science fiction to the map makers and explorers of earlier centuries. These satellite images are updated regularly, sometimes daily or even more frequently for populated areas, allowing anyone with an internet connection to explore remote mountains, dense jungles, frozen polar regions, and tiny islands that most people will never visit in person during their lifetimes. The democratization of this satellite imagery has transformed how we understand and relate to our planet, making the entire Earth accessible for exploration from a computer screen or smartphone. The whole world now fits on a screen. LiDAR technology can see through forest canopy to reveal hidden ancient structures beneath. LiDAR, which stands for light detection and ranging, uses millions of laser pulses fired from aircraft or drones to penetrate dense forest canopy and create detailed three-dimensional maps of the ground's surface beneath, revealing archaeological features that have remained hidden for centuries under layers of vegetation in jungles and forests around the world. This revolutionary technology has transformed archaeology, uncovering vast networks of ancient cities, ceremonial complexes, roads, irrigation canals, and agricultural systems in places like Central America, Cambodia, and elsewhere that would have taken many generations to find using traditional ground-based survey methods. LiDAR has revealed that ancient civilizations were often far larger and more complex than anyone had previously imagined. Laser light reveals what centuries of lives had hidden. And from the skies, we now turn to the digital revolution that transformed how we use maps. The Global Positioning System uses satellites to pinpoint your location anywhere on Earth. The Global Positioning System, or GPS, consists of a constellation of at least 24 satellites orbiting the Earth at an altitude of about 20,000 kilometers, constantly broadcasting precise time signals that receivers on the ground can use to calculate their exact position anywhere on the planet to within a few meters or even centimeters with specialized equipment. This technology, which most people now carry in their pockets in the form of smartphones, has transformed how we navigate through our world, making paper maps and printed directions increasingly obsolete for everyday travel and replacing uncertainty with confidence about where we are at any moment. The ability to know precisely where you stand at any moment is a gift that earlier generations of travelers could only dream about. Satellites have become our guides through the world. GPS was originally developed for military use before being opened to the public. The Global Positioning System was originally developed by the United States military beginning in the 1970s to provide precise navigation and targeting capabilities for military forces anywhere in the world. And for many years, civilian access was deliberately degraded to prevent potential enemies from using the system to the same level of accuracy that military users enjoyed. It was not until 2000 that this deliberate degradation was removed and the full precision of GPS became available to everyone, leading to an explosion of civilian applications from car navigation systems to hiking devices, from fitness trackers to the location services built into every modern smartphone. A technology created for military precision has become an everyday tool for billions of ordinary people. Military secrets became public navigation. Google Earth has allowed billions of people to explore any place on the planet from home. When Google Earth was first released to the public in 2005, it offered something unprecedented in human history: a virtual globe made of real satellite imagery that anyone could spin, zoom, and explore from their home computer, visiting any corner of the Earth from the peak of Mount Everest to the dunes of the Sahara Desert to the familiar streets of their own neighborhood. The application democratized access to satellite imagery that had previously been the exclusive preserve of governments, military organizations, and wealthy corporations with specialized resources, putting the power to explore the entire planet into the hands of ordinary curious people everywhere. For the first time, the whole Earth became explorable from anywhere with an internet connection. The world became accessible from every living room. Digital maps can be updated in real time, showing traffic, weather, and changing conditions. Unlike the printed maps of earlier eras, which became outdated the moment new roads were built or boundaries changed, and had to be completely reprinted to incorporate any updates, digital maps can be updated continuously and in real time, incorporating live data about traffic congestion, road closures and construction, weather conditions, and countless other variables that affect how we move through the world. Modern navigation applications do not just show you where places and roads are, but can predict how long your journey will take, suggest alternative routes when delays are detected ahead, and adjust their recommendations moment by moment as conditions change across the road network. Maps have evolved from static records into dynamic, responsive systems that learn and adapt. Living maps now guide us through our living worlds. OpenStreetMap is a free, community-built map created by volunteers around the world. OpenStreetMap represents a remarkable and ongoing collaborative effort in which volunteers around the world contribute their local knowledge and time to build and maintain a free, openly licensed map of the entire planet, with each contributor adding streets, buildings, footpaths, shops, benches, and countless other features from their own neighborhoods and travels. Founded in 2004 by a British programmer who was frustrated with the limitations of existing mapping data, the project has grown to include millions of contributors and billions of individual map features, providing detailed coverage of areas that commercial mapping services often neglect or represent poorly. In times of humanitarian crisis, OpenStreetMap volunteers have rapidly mobilized to map disaster zones to aid relief efforts. The whole world is being mapped by the people who actually live in it. Modern cars contain more mapping technology than entire navies possessed a century ago. A typical modern car contains GPS receivers, detailed digital maps stored in memory, real-time navigation systems with voice guidance, and sensor technologies that together provide more accurate positioning and mapping capability than the combined resources of entire naval fleets, possessed just 100 years ago when ships relied on paper charts and celestial navigation. The navigation systems that we now take completely for granted, that quietly and reliably guide us through unfamiliar cities and along complex motorway junctions without any conscious effort on our part, would have seemed impossibly sophisticated and almost magical to the most advanced military planners and cartographic experts of the early 20th century. We carry more navigation power in our dashboards than admirals once commanded from their bridges. Our daily commutes now surpass historical expeditions in precision. And from our map-filled present, we now explore the places that remain difficult to map. The ocean floor is less well mapped than the surface of Mars. Despite the fact that over 70% of our planet's surface lies beneath the oceans, we have better and more detailed maps of the dry, dusty, and distant surface of Mars, hundreds of millions of kilometers away through the cold vacuum of space, than we do of the vast underwater landscapes that lie just a few kilometers beneath the waves of our own seas. The oceans present unique and difficult challenges for mapping, as light cannot penetrate the depths where the water absorbs it completely, and sound waves travel slowly through water, making detailed surveying extremely expensive and time-consuming compared to the orbital photography that has efficiently mapped the visible surfaces of other worlds in our solar system. There is a strange irony in knowing distant planets better than our own ocean floors. The nearest frontier remains the least explored. Only about 20% of the ocean floor has been mapped in high resolution. While lower resolution satellite measurements of ocean surface gravity have allowed scientists to infer the approximate shape of the entire ocean floor, revealing the general locations of major underwater features, only about 20% has actually been mapped using direct sonar surveys at the high resolution needed to reveal the detailed features of underwater mountains, deep valleys, volcanic ridges, and vast abyssal plains. The remaining 80% of the ocean floor remains essentially unexplored in any meaningful detail, a vast unknown realm beneath the waves where countless discoveries await future generations of oceanographers, marine geologists, and underwater cartographers. Mapping this hidden world beneath the waves will require decades of dedicated survey work and new technologies. Most of our planet's surface still remains to be properly mapped. Underwater sonar is slowly revealing mountains and valleys hidden beneath the waves. Ships equipped with multi-beam sonar systems are slowly and painstakingly building up detailed maps of the ocean floor, carefully sending sound pulses down through the water and measuring the echoes that return to reveal the shapes of underwater mountains, valleys, ridges, and ancient plains that have never been seen by human eyes. These surveys reveal an astonishing hidden landscape beneath the waves, with mountain ranges taller than any on dry land, trenches deeper than any canyon, and vast flat abyssal plains stretching for thousands of kilometers across the perpetual darkness far below the sunlit surface waters. Each survey voyage adds new details to our understanding of this hidden world, slowly filling in the blank spaces on our maps and charts of the deep ocean. The unseen seafloor is revealing its ancient secrets to patient listeners. Cave systems present unique challenges for mappers, requiring three-dimensional thinking. While most maps represent surfaces as two-dimensional planes viewed from above, cave systems twist and burrow through the rock in 3 dimensions, with passages that loop over and under each other, shafts that plunge vertically for many hundreds of meters, and chambers that open up into vast underground cathedrals that are impossible to represent on any flat piece of paper. Cave surveyors must carry their mapping equipment through tight squeezes, across underground rivers, and down steep vertical drops, carefully measuring angles and distances with specialized instruments that can function reliably in complete darkness and high humidity. The resulting maps require special conventions to show the vertical relationships between passages that cross at different levels. Underground labyrinths demand entirely new ways of seeing space. The deepest parts of jungle canopy remain difficult to map even with modern technology. Despite all of our many technological advances, the dense jungles of the tropics still present significant challenges for mappers, with multiple layers of vegetation creating canopies so thick that even powerful LiDAR laser pulses cannot always penetrate fully to the forest floor to reveal what lies beneath the leaves. In the deepest rainforests, where giant trees rise to heights of 50 meters or more and multiple understory layers block light and signals, detailed mapping of the ground surface remains quite difficult and expensive, requiring either extensive ground surveys through very challenging terrain or multiple passes with sophisticated scanning equipment from the air above. Some of the most biologically rich landscapes on Earth remain among the hardest to map in any detail. Dense leaves guard their secrets from the sky above. And from the unmapped places of Earth, we now look outward to the mapping of other worlds. The Moon was mapped in detail before many parts of the Earth's ocean floor. In a remarkable irony of exploration history, the entire visible surface of the Moon, our closest celestial neighbor hanging bright in the night sky, was mapped in high detail by orbiting spacecraft many decades before we had comparable maps of large portions of our own ocean floors lying hidden beneath the waves below. The Lunar Reconnaissance Orbiter and other dedicated missions have photographed every crater, mountain, and plain on the lunar surface to impressive resolutions of just a few meters, while vast stretches of Earth's underwater landscapes remain essentially unmapped and unexplored. The reason is simple: light travels easily through the vacuum of space, but cannot penetrate the depths of our oceans, making distant worlds easier to photograph than the hidden realm beneath our own waves. We knew the Moon before we knew our own seafloor. Mars has been mapped by orbiting spacecraft to a resolution of just a few meters. Multiple spacecraft orbiting Mars have photographed the entire surface of the red planet in extraordinary detail, with cameras capable of resolving features just a few meters across, revealing the planet's vast volcanoes, deep canyons, ancient river channels, and windswept dunes in stunning clarity, despite the fact that Mars lies tens of millions of kilometers away at its closest approach to Earth. These detailed maps have allowed scientists to study Martian geology in remarkable detail and have helped mission planners select safe and scientifically interesting landing sites for rovers and landers exploring the Martian surface up close. We can zoom in on Martian landscapes with a precision that would have seemed like pure fantasy to astronomers of just a few generations ago. A distant world is now mapped better than most of our seafloor. Cartographers have named features on other planets and moons using mythological and literary references. As spacecraft have revealed the detailed surfaces of other worlds, cartographers have needed to name the countless craters, mountains, valleys, and plains that fill these alien landscapes, and they have drawn on mythological and literary traditions from around the world to provide fitting and evocative names for features on distant planets and frozen moons orbiting far from our sun. Craters on Mercury bear the names of artists and composers, mountains on Venus are named for goddesses from many cultures, and features on the moons of the outer planets carry names from various mythologies and ancient legends. These naming conventions are overseen by the International Astronomical Union, ensuring consistency and appropriate recognition of human cultural heritage. Our ancient myths now live on the surfaces of distant worlds. Planetary map-making faces challenges unknown on Earth, from extreme temperatures to toxic atmospheres. Mapping other worlds presents challenges that cartographers working on Earth have never had to face. From the extreme cold of outer planet moons, where temperatures drop to hundreds of degrees below the freezing point, to the crushing pressure and searing heat of Venus, where spacecraft survive only briefly before succumbing to the hostile conditions of that world. On some worlds, dense clouds of toxic gases completely obscure the surface, requiring radar to penetrate the veil and reveal the landscape beneath the clouds. On others, the surfaces constantly change as volcanoes erupt or geysers spray material across the changing terrain. Each new world presents its own unique challenges for the cartographers working to map them from the safety of Earth. Alien environments demand entirely new approaches to the ancient art of mapping. Future colonists will need detailed maps of alien worlds before setting foot on them. If and when humanity eventually establishes permanent settlements on the Moon, Mars, or mysterious worlds beyond our solar system, those determined future colonists will depend on detailed maps created by robotic explorers and orbiting spacecraft long before any first human foot touches alien soil. Detailed maps showing where water ice might be found, where the terrain is safe enough for landing spacecraft, and where precious resources might be extracted to support human life far from Earth. Just as explorers of earlier centuries relied on charts made by those who came before them, future space travelers will rely on the maps we are creating today from images sent back across millions of kilometers of empty space. The maps being made by our spacecraft today will guide the pioneers of tomorrow. We are carefully mapping the future homes of humanity. And from the maps of distant worlds, we now return to the quiet philosophy of what maps mean to us. A map is never a complete picture of reality, only a selection of what the mapmaker chose to show. No matter how remarkably detailed or carefully made, every map is fundamentally an abstraction, a selection of certain features from the infinitely complex reality of the entire world, chosen by the mapmaker to be represented, while countless other features are left out or simplified beyond recognition and reduced to symbols. A road map shows roads, but not the flowers growing beside them. A political map shows borders, but not the people who live within them or cross them daily. Every act of mapping is an act of selection, choosing what matters enough to show and what can be safely or wisely omitted for the current purposes at hand. Understanding this fundamental truth helps us see maps not as objective truths, but as carefully and deliberately constructed representations of the world. Every map is a choice about what to see and remember. Every map tells us as much about its maker as about the territory it represents. When we look at a historical map, we see not merely a representation of geography, but a window into the mind and priorities of the person or culture that created it, quietly revealing what they knew, what they valued, what they secretly feared, and what they hoped to achieve by creating the map in the first place. A medieval map with Jerusalem at its center tells us about the religious worldviews of that era. A colonial map with vast empty spaces tells us about the erasure of indigenous knowledge and peoples. A modern digital map optimized for driving tells us about our car-centric culture and values. Every choice made in creating a map tells a story about the mapmaker as well as the territory being mapped, making cartography as much a deeply human document as a geographical one. Maps reveal both landscapes and the minds that map them. Let these quiet reflections settle gently within you, like contour lines traced on gentle hills. There is no destination to reach tonight. Simply let your body soften, your thoughts slow, and allow the stillness to embrace you. The borders on a map are human inventions, invisible lines that mean nothing to rivers or birds. The bold lines that divide one nation from another on our political maps are entirely human creations, invisible constructs that exist only in our laws, our treaties, and our minds, meaningless to the rivers that flow across them, the birds that migrate over them, and the mountains that stand indifferent to the bright colors we paint on either side. These lines have been drawn and redrawn countless times throughout history, shifting with wars, treaties, marriages, and revolutions, each change creating new realities for the people living along them, while the land itself remains unchanged. Understanding that borders are human inventions rather than natural features helps us see maps as political documents as much as geographical ones, documents that reflect human choices and human power. The lines we draw reveal who we are. Place names carry stories within them, compressed histories of who lived there and what they saw. Every place name on a map is a compressed history, a story folded down into just a few syllables that hint gently at who lived there, what language they spoke, what they saw when they first arrived, and what mattered enough to them to become the name that stuck through the passing centuries. Names derived from old words for river, hill, or forest tell us what features dominated the landscape. Names derived from personal names tell us who once owned or settled the land in ages long past. Names imposed by colonizers tell us about conquest and erasure, while indigenous names preserved on modern maps tell us about resistance and survival. Each place name is a tiny and precious museum of linguistic and cultural history, waiting to reveal its secrets to those who pause to listen. The names on maps whisper their ancient stories. Some maps show what could be rather than what is, imagining future cities and vanished forests. Not all maps are records of what exists. Some are visions of what might be, showing carefully planned cities before a single building is constructed, imagining restored forests where farmland currently lies, or depicting proposed transit lines that may or may not ever carry passengers. Urban planners use maps to visualize cities decades before they are built. Environmentalists use maps to show what landscapes looked like before human alteration and what they could become with careful restoration. And architects use maps to imagine buildings that exist only in imagination and blueprints. These forward-looking and backward-looking maps remind us that geography is not fixed and permanent, but is constantly being shaped by human choices and natural processes alike. Maps can show us possible futures as well as our past and present. Mental maps exist in our minds, personal geographies of familiar and foreign places. Beyond the paper and digital maps that we can see and touch, there also exist mental maps within our minds, personal geographies built from experience, memory, and imagination that guide us through familiar neighborhoods and help us imagine places we have never visited in person. These internal maps are often distorted in interesting ways, with frequently visited places appearing larger and more detailed than they actually are, while distant or unfamiliar regions shrink or blur into vagueness. Our mental maps quietly reveal what matters to us, which routes we travel, which places feel safe or dangerous, and which regions remain mysterious and unknown to us. Cognitive scientists study these internal geographies to understand how we navigate and make sense of the vast and complex world around us. Each of us carries a unique atlas in our mind. Your own mental map is different from anyone else's, shaped by memory and experience. No two people carry exactly the same mental map, because each person's internal geography is shaped by their own unique experiences, their own travels, their own memories of places visited and stories heard, creating a personal atlas that no one else shares in quite the same way. The routes you travel daily become deeply etched in your mental map, while places you have never visited remain vague or imaginary. The locations of meaningful events become landmarks in your personal geography, charged with emotion and memory in ways that would be invisible to others. Your childhood home might loom large in your mental map long after you have moved away, while vast regions you have never explored remain blank or filled with imaginings. Your mental map is as utterly unique and personal as your fingerprint. No one sees the world quite like you do. Children draw maps that reveal what matters most to them, placing their homes at the center of the world. When children draw maps, they create windows into their priorities and perceptions, placing their own homes at the center of the world, with familiar places like school and grandparents' houses nearby, while distant locations shrink or disappear entirely. These childhood maps are honest representations of experienced geography, showing the world as it feels rather than as it would appear from above, with paths to favorite places drawn large and clear, while unfamiliar routes fade away. As children grow, their mental maps expand outward, incorporating new places and gradually aligning more closely with conventional cartographic representations, though they never entirely lose their personal quality. Children's maps remind us that all mapping begins with personal experience. The heart of every map is the place called home. The blank spaces on maps have shrunk over centuries, but the world still holds undiscovered places. Over the centuries of exploration and mapping, the blank spaces on our maps have steadily shrunk as explorers, surveyors, and satellites have filled in the details of continents, islands, mountain ranges, and ocean depths that were once unknown and unmarked. Yet even today, Earth still holds places that remain unmapped or still poorly understood, from the deepest ocean trenches to the densest jungle interiors, from vast cave systems extending far beneath our feet to the constantly changing surfaces of glaciers and active volcanoes. And beyond our own planet, entire worlds await their first detailed maps. The age of discovery is not over. It has simply expanded to new frontiers that challenge our instruments and imagination in quite different ways. There are still blank spaces patiently waiting to be filled with knowledge. To study old maps is to see the world through the eyes of those who came before. When we very carefully examine old maps in museums and archives, we are not simply looking at merely outdated geographical information, but are seeing the world through the eyes of those who made them centuries ago, experiencing how they understood their world, what they knew and what they imagined, what they feared and what they valued enough to record. An old map with sea monsters in the margins tells us about the fears and imagination of medieval sailors. A map with indigenous territories erased tells us about colonial attitudes and intentions. A map centered on a particular city tells us about where power and importance were located in that age. Historical maps are documents of human consciousness as much as geographical records, and studying them opens windows into vanished worldviews. Old maps are time machines made of paper and faded ink. Every map is a kind of hope, a belief that the world can be understood and navigated safely. At its heart, every map embodies a kind of hope, a fundamental belief that the world can be understood, recorded, and navigated safely, that despite all its vastness and complexity, the Earth can be reduced to lines and symbols that guide us from one place to another without becoming lost in the wilderness. To make a map is to express faith in human reason and observation, to believe that careful measurement and thoughtful representation can capture something true and useful about the infinitely complex reality of our world. Maps are acts of optimism, declarations that we can find our way through whatever territory lies ahead, whether that territory is geographical, intellectual, or emotional. The simple act of drawing a map says that understanding is possible and that home can always be found. Every map is a promise of safe arrival. In the end, the greatest map is the one that leads you safely home. After all our explorations of ancient surveys and satellite imagery, of longitude problems and projection debates, of mental maps and alien cartography, perhaps the most important truth about maps is the simplest one of all, that the greatest map is the one that leads you safely home, wherever home may be for you. Whether that map is a detailed chart, a simple sketch, or a familiar route burned into memory, what matters most is that it guides you back to the place where you are known and loved. Tonight, as you drift towards sleep, let the gentle thought of maps lead you homeward, back to the familiar territory of rest and peace, back to the safe harbor of dreams. The ancient cartographers would understand. All their careful lines were drawn for this single purpose, to help the traveler find their way. May this map of quiet facts lead you safely home tonight. And with that, the lines and legends of our journey begin to fold gently into the night. We have traveled from cave paintings to satellites, from Ptolemy's spheres to Google Earth, from sea monsters at the edge of the known world to detailed maps of distant planets. We have traced the careful measurements of surveyors, the artistry of illuminated manuscripts, and the quiet power of lines drawn on paper to shape how we see everything. Maps have guided sailors home and led explorers into unknown lands, and tonight they have carried us gently toward rest. If this journey across the cartographer's world brought you peace, consider subscribing or sharing with someone who might also find comfort here. There are more wonders waiting, more gentle explorations ahead, and we are always glad when you return. Right now, as you lie here, cartographers around the world continue their quiet work. Satellites overhead are measuring the slow drift of continents. Somewhere, an oceanographer is mapping a newly discovered seamount. In a library, a scholar is carefully unfolding a map drawn centuries ago by hands long turned to dust. The work of understanding where we are never truly ends. Let your eyelids grow heavy, and if they wish to close, let them. Take one slow breath in, feeling your chest rise like a ship lifting on a gentle swell. Then let it go, slow and easy. Let your hands uncurl, your jaw soften, and your body settle into the familiar territory of your bed. There is no journey you must take tonight. You are exactly where you need to be. Tonight, as you sleep, the Earth continues its slow rotation beneath a canopy of stars that have guided navigators for millennia. Coastlines are being reshaped by waves, glaciers are creeping forward, and somewhere, a new map is being drawn that will show the world a little differently than before. You are a small, warm presence on this constantly changing surface, peacefully resting among the wonders of a world still being discovered. Sleep well, sweet dreams, and may you carry with you the quiet knowledge that no matter how far you wander in your dreams, there is always a map that leads back home. This has been Drowsy Discovery. Good night.